Imagine you're asking an AI to answer a complex, multi-layered question, not just what the answer is, but how it got there. Now suppose the AI gives you a perfect answer, but it's built on a foundation of flawed reasoning, misleading sources, or blind trust in unreliable data. How do you know? This is the heart of a growing challenge in AI research. We've been evaluating large language models, LLMs, on final answers, but we've ignored the critical steps in between. Today, we dive deep into a new benchmark called RAGCap-Bench, a revolutionary tool designed to evaluate the intermediate capabilities of agentic retrieval-augmented generation, RAG, systems. This isn't just another QA test. It's a microscope into the inner workings of AI agents as they plan, retrieve, reason, and adapt in real time. Let's unpack why this matters and how RAGCap-Bench is changing the game. The problem, when the answer is right but the path is wrong. Large language models are powerful. They can write essays, code, and even solve complex problems. But they're not perfect. They hallucinate. They get facts wrong. They rely on outdated knowledge. Retrieval-augmented generation, RAG, was a breakthrough. It gives LLMs access to real-time, external information, pulling in up-to-date facts from the web, databases, or documents. That helps reduce hallucinations and outdated knowledge. But traditional RAG systems still struggle. They're often rigid, retrieve once, reason once, generate once. They lack the ability to think through a problem, adapt their strategy, or handle conflicting or noisy data. Enter Agentic RAG, a next-generation approach where the LLM acts not as a passive generator, but as an autonomous agent. It plans, searches, analyzes, refines its strategy, and reasons iteratively, just like a human researcher. But here's the catch. If one step goes wrong, the whole chain collapses. A poor search query leads to irrelevant results. A flawed interpretation of evidence causes incorrect reasoning. A failure to detect low-quality sources forces the model to build conclusions on shaky ground. And yet, most benchmarks only measure the final answer. They don't ask, did the agent think carefully? Did it avoid traps? Did it know when to stop? That's where RAGCap-Bench comes in. What is RAGCap-Bench? RAGCap-Bench is the first comprehensive benchmark focused on intermediate capabilities in agentic RAG systems, not just the end result, but how the system arrives there. It's built on a deep analysis of real-world agentic systems like WebThinker, HiRA, and WebDancer, systems that simulate human-like research behavior. The researchers identified 4 core capabilities that drive performance in these systems. 1. Planning. Can the model break down a complex question, decide what to search for, and adjust its strategy dynamically? 2. Evidence extraction. Can it sift through dozens of search results and pick out the relevant, useful information, even when it's buried in noise? 3. Grounded reasoning. Can it reason logically using only the evidence it retrieved, avoiding hallucinations and contradictions? 4. Noise robustness. Can it detect low-quality, misleading, or unreliable sources, and abstain from answering when the evidence is too weak? Each of these capabilities is evaluated with multiple-choice questions, MCQs, carefully designed to probe the model's reasoning at every stage. But here's the genius. These questions aren't random. They're derived from real errors observed in actual agentic RAG pipelines. The benchmark doesn't just test what the model knows, it tests how well it avoids common pitfalls. How it works, from real failures to precision testing. To build the dataset, the team ran multiple open-source agentic RAG systems on real-world research benchmarks like InfoDeepSeek, Browse CompSch, and Frames. They collected the full execution logs, every search query, every retrieved document, every reasoning step, every plan change. Then they used a 2-pronged approach to generate questions. Vanilla generation. Extract real intermediate outputs and turn them into MCQs. Error-guided generation. Use LLMs to simulate common mistakes, like shallow keyword matching, hallucinated support, or forced reasoning, and design questions that expose those flaws. For example, in the evidence extraction task, a model might be shown a list of 8 web pages and asked, which one is least helpful for answering the query? Or in grounded reasoning, a model might be given a chain of reasoning with one flawed statement and asked to identify it. And in noise robustness, the model is presented with search results full of low-quality content and must decide, should I answer or should I admit I can't? These aren't just trivia questions. They're diagnostic tools. The results, slow thinking wins, but why? The team tested a wide range of models, from fast-thinking LLMs like QN2, 5-72B and GPT-4o to slow-thinking, deliberate models like QN3-235B and O1 Mini. The results were revealing. Fast-thinking models often scored well on end-to-end tasks, but struggled with intermediate steps. Slow-thinking models, despite being more deliberate, still made errors, unless given structured guidance. But here's the most important finding. Models that performed well on RAGCap-Bench also performed better on downstream, real-world agentic RAG tasks. There was a strong correlation between RAGCap-Bench scores and performance on InfoDeepSeek and Browse CompSch, 2 major benchmarks for deep research agents. This means RAGCap-Bench isn't just a proxy, it's a reliable predictor of real-world effectiveness. Even more striking, QN3-8B, a relatively small model, performed nearly as well as its larger counterparts on RAGCap-Bench and matched them in downstream performance. This suggests that capability matters more than size, and that fine-grained evaluation can reveal strengths that raw scale can't. The bigger picture, why this benchmark changes everything. Most benchmarks are like final exams, you get a grade, but you don't know why you failed. RAGCap-Bench is different. It's like a medical diagnostic panel. It identifies which system component is weak. Is the model bad at planning? Improve its reasoning architecture. Is it bad at filtering evidence? Right arrow, add better retrieval ranking or filtering layers. Is it trusting low-quality sources? Right arrow, inject credibility scoring. Is it forcing answers when it should? Right arrow, teach it to abstain. And the implications go further. The team also tested whether LLMs could evaluate their own reasoning, using the same RAGCap-Bench questions as a judge. They found that models scoring well on RAGCap-Bench also gave more accurate evaluations of their own intermediate outputs. This opens the door to self-critiquing AI agents, systems that can audit their own work, detect errors early, and fix them before they cascade. Conclusion: a new era of AI evaluation. RAGCap-Bench isn't just a benchmark. It's a paradigm shift. It moves us from end-to-end performance to process-level understanding. From did the answer work, to how did it work and where did it break. It shows that intermediate capabilities are not just important, they're the key to robustness. And it proves that you don't need a massive model to be effective. You just need the right capabilities, finely tuned and rigorously evaluated. As agentic AI systems grow more powerful, powering research, legal analysis, medical diagnostics, and more, we can no longer afford to judge them by their final output alone. We need to understand their process, their reasoning, their resilience. And RAGCap-Bench gives us the tools to do exactly that. So the next time you see an AI answer a complex question, ask not just what it said, but how it got there. Because the truth isn't in the answer. It's in the journey.